0 plus 3. So 0 is the additive identity under addition. Next is additive inverse of a matrix. If matrix Aij of order m into n, then negative of that matrix minus Aij, same order m into n, such that A plus minus A or minus A plus A is equals to null matrix, then minus A is called additive inverse of A. Minus A is called additive inverse of A. Let A is 2, 3, 1, 0, then minus A is multiplied by negative sign, minus 2, minus 3, minus 1, 0. Now A plus minus A. Add all the terms, 2 minus 2, 0, 3 minus 3, 0, 1 minus 1 and 0 plus 1. 0 plus 0 is 0. So A plus minus A is 0. Therefore minus A is called additive inverse of matrix A under addition. So these are the properties of matrices under addition. Now properties of matrix under multiplication. First one is scalar multiplication. If we multiply the matrix addition of two matrices by scalar, then we get Ka plus Kb. Let us take example. A is 4, 2, 3, 1 and B matrix is 3, 1, 2, 2. First add A plus B, 4 plus 3, 7, 2 plus 1, 3 plus 2, 1 plus 2. Now multiply this matrix by K. So what we get? 7K, 3K, 5K and 3K. Now multiply first the matrix by K and B matrix by K and then add these two matrices Ka plus Kb. 4K, 2K, 3K plus B matrix 3K, K, 2K and 2K. Now add these two matrices 4 plus 3, 7, 2 plus 1, 3, 3 plus 2 and 1 plus 2. Now these two matrices are equal. So K into A plus B is equals to Ka plus Kb. Now next in scalar multiplication, if there are two scalars, say K and L, multiply this by matrix A, that is equal to Ka plus La. Let A is 4, 1, 2, 3. K is any scalar, say 3, and L is any scalar having value 2. Now K plus L, 3 plus 2 into matrix A, 4, 1, 2, 3. 3 plus 2 is 5. So multiply the whole matrix by 5. 5 into 4, 5 into 1, 5 into 2 and 5 into 3. Now Ka, 3 into matrix A plus 2 into matrix A. Multiply the matrix A by 3, 4 into 3, 12, 1 into 3, 2 into 3 and 3 into 3. Multiply the matrix A by 2, 2 into 4, 2 into 1, 2 into 4 and 2 into 3. Now add these matrices 12 plus 8, 3 plus 2, 6 plus 4 and 9 plus 6. Now these matrices are equal. So K plus L into A is equals to Ka plus La. Now these are all the matrices under addition. Now properties of multiplication of matrices. Now multiplication of matrices AB into C is equal to A into BC, where both the sides of equality are defined. Associative law. Let A as 2, 1, 3, 2, B as A is 2, 1, 3, 2, B is 4, 3, 2, 1 and C is 6, 3, 2, 2. First multiply AB. In multiplication what we have to do? 2 into 4. This element, first element into first, 2 into 4, 8 plus 1 into 2. फर्स्ट रो को पहले हम मल्टीप्लाई करेंगे फर्स्ट कॉलम से 2 into 4 plus 1 into 2. Second row first column, second row first element 3 into 4 plus 2 into 2. Now first row second element, first row को second column से मल्टीप्लाई करेंगे 2 into 3 6, 1 into 1 1. Now second row second element, so second row multiply by second column 3 into 3 9, 2 into 1. So this is 10, 7, 16 and 11. Now AB into C, multiply AB into C, multiply this by C. 10 into 6, 60 plus 7 into 2, 16 into 6, 11 into 2, 10 into 3, 7 into 2, 16 into 3, 11 into 2. So what we get? AB into C is 74, 70 and 180. Now A into BC. First multiply BC. First row by first column. 4 into 6, 24 plus 3 into 2. 2 into 6, 2 into 1. 4 into 3, 3 into 2. 2 into 3 and 2 into 1. So BC is A. Now multiply BC by A. BC is 30, 18, 14, 8 and matrix A is 2, 1, 3, 2. Multiply these matrices 2 into 3, 14 into 1, 3 into 30, 2 into 14, 18 into 2, 1 into 8, 18 into 3, 8 into 2. So that is equal to so these two matrices are equal. So multiplication is associative. Now next property is distributive law. distributive law is applicable under multiplication. You can take any example and prove that. Next property is existence of multiplicative identity. Existence of multiplicative identity. Let A be any matrix. For every square matrix A, there exists an identity matrix I. Write down. For every square matrix A, there exists identity matrix I such that I into A or A into I is equals to A. Let A is 2, 0, 5, 2. This is of order 2, so identity matrix will also be of order 2. Now A into I, 2 into 1, 2, 0 into 0, 5 into 1 plus 2 into 0, 2 into 0, 0 into 1, 5 into 0, 2 into 1, 2, 0, 5, 2. That is equal to A. Similarly, for IA, it is also equal to A. That is, for every square matrix A, there exists identity matrix I such that A into I or I into A, that is equal to A. Next is transpose of a matrix. Transpose of a matrix. Let A is equals to Aij with matrix of order m into n. A matrix. Let A is equals to Aij is a matrix of order m into n. Then matrix obtained by interchanging rows and columns. Rows and columns is called transpose of matrix A. Let A be a matrix. Let A is a matrix 3, 5, square root of 3, 1, 0, minus 1 by 5. In this matrix, we have 3 rows and 2 columns. Now, transpose of matrix, we can denote A transpose as A power T or A dash. So, change rows into columns and columns into rows. Change first column into first row. It becomes 3 square root of 3, 0, 5, 1 minus 1 by 5. Here order or number of rows are 2 and number of columns are 3. So matrix after interchanging rows and columns is called transpose of the matrix. Properties of transpose of the matrix. If we take matrix A, transpose of matrix and again the transpose of that matrix, that is equal to the given matrix, that is A. Let A is 2, 3, 4, 1. Then A transpose, change rows into columns, 2, 3, row, change into column, 4, 1. If we again take the transpose of that matrix, A transpose, 2, 4, 3, 1, that is equal to matrix A. So A transpose is equal to matrix A. 0, 4, 2. Add the terms 2 plus 3, 4 plus 4, 3 plus 0 and 1. 3 plus 0 and 1 plus 2, 3. So 5, 8, 3, 3, these two matrices are equal. Therefore, A plus B transpose is equal to A transpose plus B transpose. Next, fourth property is A into B transpose, that is equal to B transpose into A transpose. You can solve it by taking any example. Now the next one is symmetric matrix. Symmetric matrix, a square matrix A is equals to Aij. Write down. A square matrix A is equals to Aij of order m into n is said to be symmetric if A transpose is equal to A. If A transpose is equal to A. Let A is root 3, 2, 6. A is root 3, 2, 6, 2, minus 5, minus 1, and 6, minus 1, 1. Now take the transpose of this matrix. Root 3, 2, 6, 2, minus 5, minus 1, 6, minus 1, 1. It is equal to matrix A. So, a square matrix A is equals to Aij of order m into n is said to be symmetric if A transpose is equal to A. Next is skew symmetric matrix. A matrix, a square matrix A is equals to Aij of order m into n. A square matrix A is equals to Aij of order m into n is said to be skew symmetric if A transpose is equal to minus A. If A transpose is equal to minus A. Let A is 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. Now take the transpose of this matrix. 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. Take negative common. 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. So that is equal to negative of A. So matrix A is said to be skew symmetric if transpose of that matrix is equal to negative of that matrix. Next one is invertible matrix. If there is a square matrix A, if there is square matrix A of order m, then there exists a square matrix B of